Regression is one of the possible machine learning technique that you can use if you want to predict a value based on values you've already collected. So let's look at the different methods that we have in machine learning. So machine learning can be divided into broad families of algorithms. For instance, we can start with machine learning that is supervised, or what is also known as supervised learning. So what is supervised learning? Well, supervised learning happens when you have data, and that data is labeled. By this I mean you have a collection of data and you know what this data is. So in this example, you see that we have some gastropods, some quartz crystals, and some bivalves, and we have the label for this data. So in supervised learning, you take the data and the label and you train a model. Because this model is trained on the data, you can make a prediction. And usually what you do is you use unlabeled data, so data where you don't know the label, and your prediction is to output the label for that new data. So what are the types of supervised learning that exist? We recognize two different types of supervised learning. One is classification, and the other one is regression. Let's have a look at both of these types. Classification is when you have different classes, and what you want when you look at these classes in a feature space, the two arrows here represent two features of the data. What you want is to be able to separate them into distinct classes. Regression is different. With regression, what you do is you take your data and you have a continuum measure or a feature that happens on a continuous scale. And what you want is use the data to have a model that gives you the ability to predict a continuous value, and that's regression. There are also unsupervised algorithms. So unsupervised learning usually means clustering. What's exciting about unsupervised learning is that you don't need to have a label. You can actually throw data at an algorithm and it will try to make sense of it based on the structure of the data itself. So for instance, in clustering, if you give this data to a clustering algorithm in their different feature space, what the clustering algorithm will try to do is to separate this data into clusters. In this case, if you do it well, you will find 3 different clusters. One of the challenge, of course, is to give the right number of clusters when you train your algorithm, and that's not always trivial. There's one more family of machine learning that's prevalent and very common, and that's reinforced learning. And reinforced learning or reinforcement learning usually is used for control experiment. So most of the time, control experiment means controlling a robot or controlling a remote vehicle. And the principle of reinforcement learning is actually quite interesting. So in reinforced learning, you still have your input data that is raw data. You give it to the reinforcement learning algorithm, and this is a bit more complex because the reinforcement learning algorithm has several key components. It has an agent, and the goal of the agent is to select an algorithm and the hyperparameters of this algorithm. Then it applies the algorithm to the data, and so that's basically its best action. And now comes the second player in this reinforcement learning loop, which is the environment itself. Now the environment will test the agent and its best actions, and depending on how well the agent performs, it will give it a reward. So that can be a positive or a negative reward. And through that learning, the agent knows how to change the algorithm. So through trial and error, it will find the best solution for that particular problem. And eventually, if you do a classification exercise, it will output the best classification. But again, mostly this reinforcement learning is used for robotic, is used for things like learning or teaching robot to walk. So in earth sciences, it's not a very common method, but it has a lot of potential, and it's probably something that we should explore a little bit more as geoscientists.